Hi, I'm Garrett and welcome back to the channel. Today I'm going to start building the air system that will power my pneumatic engraver. I thought when I started building this that it would be a pretty straightforward part of the build that I could get done in one episode. However, when I got to work, some of the parts took a lot longer, so I decided to break this up into 2 episodes. This is almost everything I need to make my air system. Electricity will come in through the cord, go to a on-off switch, and then to the power supply. This is a 12 volt 15 amp power supply, which is more than enough to run both the compressor plus a few odds and ends here. The compressor will be hooked up to the power supply via this motor speed controller. This will just allow me to control how fast the compressor will oscillate the air back and forth. This compressor is a pretty simple deal. It is designed to hook up to the cigarette lighter of your car just to inflate the tires. It has a piston in here that goes up and down to compress the air. However, I will modify that so that it only cycles air back and forth and doesn't actually compress the air. I will remove the handle here and plug up the hole that it goes into so that air can't pass out this way. I will also remove this gauge here and make my own hose barb to thread into the fitting that this threads into. This surgical tubing here will be what connects the compressor to the pneumatic handpiece. In between the compressor and the handpiece though will be this pneumatic foot pedal. This will just allow me to control how much air is getting from the compressor to the handpiece itself, giving me a little bit of variability in the power. I'm also going to rig up this switch here to the foot pedal. That way, only when the foot pedal is pressed will the compressor turn on. I also have a pretty beefy cooling fan here that will just circulate air through the ammo can, keeping everything from overheating. Before modifying the compressor, I need to make a couple of hose barbs. The first one will get screwed into the compressor itself. It has 2 flats here and here that a wrench can be used on to tighten it down, as well as a 1/16 NPT thread that matches the thread in the compressor. For both the hose barbs, I'm going to be using some 1/2" 1045 steel. This is just some steel I had laying around from a previous project. First, I'm going to be machining the wrench flats here. Using the 5C collet block to hold the bar, I'm marking out a rough location for where the flat should go. I will locate all other dimensions off of this flat. With the collet block mounted in the mill, I first make a skim pass to touch off my end mill. Then I machine the flat to the final depth. I designed this to go down about 60 thousandths of an inch or so for no other reason than it looked right. Flipping the part over, I machine the other flat, and because of how cool 5C collet blocks are, the flats are perfectly perpendicular and in line. Removing the bar from the 5C collet block, I'll move over to the lathe. After getting the stock chucked up in the lathe, I'm first touching off my tool on the left side of that flat. Zeroing the dial indicator on the carriage, I can now machine the overall length down to the final dimension. Next, I will turn down the stem that will be threaded with a 1/16 NPT thread later on. For those of you who are curious, the stem is 5/16 of an inch in diameter for the 1/16 NPT die. Finally, before cutting the threads, I cut a thread relief groove here with a grooving tool and a simple chamfer filed in just to help the die get started. I'm using the tailstock of my lathe here just to help get the die started square to the stem. Then it's just a matter of slowly working the die until the threads go all the way up the length of the stem. A NPT thread is a taper thread which allows for better seal to be made since the parts will wedge themselves together. These are the first NPT threads I've made, so I'm being extra careful. The threads look good, which means I can now move on to drilling out this hole that goes through the hose barb. Starting the hole with the center drill, I'm going as deep as possible without contacting the NPT threads before switching to a 3.6mm drill. That large taper from the spot drill will just help the air flow through the hose barb. Next, I'll turn the barb part of the hose barb here. I switch to a left-handed turning tool and touch off the other side of the flat. Immediately, I run into issues. At first, I thought the insert was chipped, so I took it out and flipped it around. It cuts better, but still not great. I tightened down my compound slide to see if that was the issue, and it's better, but still struggling to cut. You can see the smoke coming off the part, showing just how hot it is. Instead of trying to fight this, I switch over to the grooving tool, which works like a charm. I finish turning down the stem to the final diameter of the hose barb here, before I turn down the smaller diameter behind the barb. I'm being very careful with this groove. At the final diameter, there will only be a wall thickness of 15 thousandths of an inch, which makes this the most delicate part I've turned on this lathe. Thankfully nothing goes wrong, and I part the hose barb off from the parent stock. Flipping the hose barb around, I remount the lathe and file in the taper on the barb. It's now time for a test fit, so I remove this pressure gauge from the compressor and then thread in my hose barb. The fit of the NPT threads is perfect. There's just 1 or 2 threads left sticking out above the top, which is exactly how far I hoped this would thread in. With this hose barb complete, I can move on to the second hose barb. This hose barb connects the air hose on the inside of the ammo can to the air hose on the outside of the ammo can. It has a locating boss here that will keep it centered in the hole I'll drill in the side of the ammo can. It also has 5/16 18 threads that a nut will thread onto to secure the hose barb in place. Just like with the last hose barb, I will first machine the wrench flats here. Everything is set up in the mill from the last hose barb, so I can just start machining the wrench flats without having to touch off my end mill. This is definitely a benefit of commonizing the design of these two hose barbs. With the bar mounted in the lathe, I can use the grooving tool again to touch off the right side of the flat before moving the grooving tool over the width of the insert and re-zeroing the indicator on my carriage. This has the zero to be on the right side of the flat, if that makes sense at all. Anyways, just like with the last hose barb, I first turn down the overall length to the final dimension. All that I'm doing here is marking out the area that is safe to machine away. The lathe is still zeroed with the grooving tool for when I come back to it, but I switch over to my right-handed turning tool to get the stem down to the final dimension. In case you're curious, when I was swapping out my left-handed turning tool for my right-handed turning tool, I figured out what was wrong. As you can see here, the holders are definitely not the same height. The tool on the left was the one that was rubbing and causing me all the issues on the last hose barb, which makes sense for how much taller it is. Just keep that in mind when buying all your cheap tool holders to not assume they're all made to spec even if they came out of the same set. The stem is now down to 5/16 of an inch, which is what I need to make these 5/16 18 threads. I will once again use the tailstock of my lathe to get the die started square before moving everything out of the way so I can really get to work cutting these threads. This was a pretty difficult thread to cut. The chuck of my lathe couldn't grip the stock tight enough to keep it from spinning. I was going to take it out of the lathe and go to a bench vise to finish cutting the threads, but then I realized I have wrench flats on this. So instead, I decided to keep the part in the lathe and use a wrench and just kind of muscle my way through it. This didn't turn out to be the best idea. I got the threads cut, but if you look carefully, you can see the nut wobbles as it goes on, meaning I bent the threads while making them. I double checked that there isn't any runout in the actual stock from rechucking it in the lathe, but as you can see there's virtually no runout, which means I bent the threads for sure. That's why I cut the threads first. That way if there's any mistakes, I will still have enough material left to finish the part. Switching back to the grooving tool, I will first cut in this locating boss here, and then move over a little bit to cut this thread relief groove here. This groove just marks out where this shoulder will be as a reference for when I switch back to my normal turning tool to turn the outside diameter of the hose barb. Switching back to the grooving tool again, I cut this relief section behind the barb. With all the features on this side of the hose barb turned, I will now drill the hole that goes all the way through the hose barb. This is a pretty deep drilling operation. I'm retracting the drill from the hole often to clear the chips. A depth of 5 times the width of the drill is the recommended max depth for a drilled hole, and I'm going well over 10 times that width for this hole. Thankfully, everything goes smoothly, and I can move over to the other end of the hose barb. Instead of using the left-handed turning tool that gave me all the issues earlier, I decided to just remove all the material with the grooving tool and turn the relief groove behind the barb as well. I part off the hose barb and try remounting it in the lathe to file the taper on the barb, but as you can see here, I'm having a lot of trouble getting it centered in the lathe. I decided to be clever and use my centering tool to get the part centered. However, this was a mistake. This hose barb is trashed now. The stem on the right is bent and cracked, the threads aren't straight, and overall there's just a lot of damage for how this dismounted from the lathe. 10 out of 10 for style, but 0 out of 10 for quality. Thankfully for you, with the magic of video editing, I already have another one made. This hose barb turned out exactly how I wanted it to, and to be honest, I was actually kind of happy when I ruined the last one so I could remake it and fix all my mistakes. The only difference in the process was I machined a flat onto the bottom end of the stock, that way when I cut the threads, the flat would keep the part from spinning in the vise. This is what I should have done the first time I made this. I also got the hose barb centered manually in the lathe and was very careful when filing in the taper on each end. With this hose barb now complete, I'm going to modify the compressor. I first need to take off the cap, which should be easy, but the first screw now is stripped, which is just a great start to this modification. I decided to move on to the next screw, and the 3 remaining screws come out easily with a flathead screwdriver. Coming back to that first screw, I try the flathead screwdriver on it, but no dice. I try another flathead screwdriver, and again, no dice. Once again, no dice with a wrench style screwdriver. I try some vice grips, and no dice. I even tried a little bit of heat, and no dice. I was pretty frustrated at this point, so I took it off screen and stopped filming so I could just worry about getting the screw out, With a little bit of gentle coaxing with a power drill at full speed, full torque, and leaning all my weight into it, I broke the screw loose, and now it comes out easily. After all that, I can remove the cover and see how this compressor works. It has a flap that acts as a check valve here, and there's another flap on the piston as well. Both of these need to be removed and the hole in the piston plugged. To remove the piston, I take off the snap ring and then remove the piston liner before the piston itself comes out. I decided to try using a little bit of brute force and ignorance to try to get the flap off, and after a little bit of effort with a couple of pliers, I got that first flap removed. I also removed this O-ring as well, which I don't know if it's necessary to do, but I figured I might as well while I have it taken apart. Moving on to the piston, I decided to use a little bit more brute force and ignorance since it worked so well the first time, and this second flap popped off instantly. I need to plug this hole so that the air can't go through it. I think this 1/4-20 bolt will work. I run a 1/4-20 tap through the hole and do a quick test fit to confirm that yes, the bolt will work. In its current state, this bolt is too long, so I modify it and turn it into this plug. All I did was to cut the threads as short as possible, cut a slot into the thread side of the plug, and ground off as much of the head of the bolt as possible. After thoroughly cleaning all the parts and applying a little bit of Loctite, I can start the bolt from the underside of the piston, and then using a small screwdriver, screw the plug in from inside the threads, which is a little weird to do because lefty-loosey and righty-tighty doesn't apply here. But that plugs the hole perfectly. To finish modifying the cover, I'll remove the stem that has the hose connection on it, and what I'm left with is just a 1/16 NPT hole to fill. As much as I want to make my own plug, I'll use this off-the-shelf NTP plug to plug this hole. I really like this thread sealing compound over Teflon tape to seal threads. It has its drawbacks as well, but overall I think it does a better job. I apply some of that thread sealing compound to the hose barb that goes into the compressor and screw it in, tightening it down with a wrench. With that, the cap and the piston are now modified and I can reassemble the compressor. The piston goes in first and then is secured in place with a snap ring, which only took me about 20 tries before I finally got it back in. The piston liner is put back and the aluminum heat sink thing or whatever is put back in place. I add a little bit of air tool oil just to lubricate the piston since I wiped most of the oil off earlier. Replacing that top check valve disc, I can put the cap on and screw it in place. Finally, I screw back on this vinyl cover, and with that, the compressor is modified. At this point, I really want to do a test run to see this graver working. To wire up the compressor, I cut off the cigarette plug, pull apart the wires, and strip the ends of the wire. I take my power cord and strip off the ends of the wire and connect all the wires to the power supply. Taking my tubing, I attach one end to the hose barb in the compressor and the other end to the handpiece. And now for the moment of truth. It works like a champ. You can see that little hammer piston moving up and down, pushing out that collet. If I didn't have my finger there, that collet would come flying out.
Off camera, I put in this graver blank just to kind of see how the whole system would feel biting to some steel, and this can actually cut lines with a non-sharpened graver. The fact that I can cut these lines with my handpiece and an unsharpened graver blank is kind of mind-blowing to me. These are the exact kind of lines I wanted it to make when it's fully functioning, so the fact that I can do it now makes me so happy. I can't wait to get the rest of the air system built up and sharpen the graver blank so I can really put this through its paces.
Thank you as always for deciding to spend your time with me here in the shop. I'll see you again in the next episode where I'll finish the air system and cut ships with a fully functioning graver.